there are two charges, then what happens between these two charges, right? So there is this Coulomb's law, and this law talks about what? You guys have already studied, right? So this law talks about what?
The
Yes.
force of attraction and repulsion between two
Yeah.
point charge.
Yes.
Yeah, and then how
So
they're proportional to the product of the magnitude of two charges
yes,
and
good.
inversely proportional to the square of the distance. And it's
Hmm.
acted along the line.
Yeah.
Uh,
Okay. So which means that we can skip so many things, right? So it talks about the force, right? So the quantity, the physical quantity that this Coulomb's law talks about is it is about the force, right? And what would be the magnitude of that force? So I will not write that it is directly proportional to the product of the, because those things you guys have already studied, right? So I will directly write that, let's say we have these two charges and the separation between them is R. So the magnitude of force would be, as Zara stated, this would be this thing, right? Where this k is very important. So this k is 1 by 4 pi epsilon naught, and then q1, q2 divided by r. So this value of k, this value of k is 9 into 10 to the power. So this one is easy to remember, right? This is a constant. And it is made up of this pi and this epsilon naught, but this is easy to remember. And what is the unit of this thing? So this K is Newton meter square and then per coulomb. So this is K. Right. Now, now there is this very important quantity. This is epsilon. So what does this epsilon naught signifies? Can you guys tell me?
permittivity of space.
Yeah. So this is a permittivity of free space, right?
Hmm.
And which means that this signifies that the force is also dependent upon the medium, right? So if the medium changes, the force will also change. So we already know that the force is dependent upon the charges, and it is also dependent upon the separation between charges. But it is also, so epsilon naught signifies that force is also dependent on the medium. Right, dependent, why would I write? On the medium, right? Where this epsilon naught is the permittivity of, right? And the value is 8.85 into 10 to the power minus 11. You can calculate the value, right? How we can calculate the value of epsilon naught? Yes. How we can calculate the value of this epsilon? So this, yeah, this k is 1 by 4 pi epsilon, right?
Yeah.
So this epsilon naught would be, uh,
Hmm.
yeah, so this would be 1 by 4 pi k, right? So which means that this is 1 by 4, pi is 22 by 7 or 3.14, and then this k is 9 into 10 to the power, right? You solve this thing and the answer would be 8.85 into 10 to the power minus 7 or minus 12, whatever. So you guys can. So this is the epsilon naught, which is Coulomb square or Newton meters, right? So this is the value of this epsilon. Now, if we put this thing, if we put these two charges in the medium, right? So let's say that, okay, before we talk about this thing, so we also have the direction of is dependent on polarity of charge. Right. So let's say that if I have this plus Q and this is also plus Q. So if I calculate the direction of the force at this point, so this would be right or left due to this force. At this point, yes,
Sir, it will be at left.
left would be attractive. Left, which will mean that this thing is attractive, right?
Yes.
So which means that this should be right, right?
Good, good.
Right.
Yeah, then it will be repelled towards this side. Yes, at right.
Yes, yeah, yeah. So this would be right. And if I take, let's say this is minus Q, and let's say this is also minus Q. So what would be the force at this point? Right or left?
Left. It will be attracted towards this. Okay, the same thing. Sorry, I felt
Same
it's
thing.
yeah,
Same
yeah.
thing. Yes, good, good. So now you guys know how can we write the direction, right? And as Zara said, this would be along the line of
Yeah,
these two charts, right? So this would be
yeah.
along the line of these two charts. So if I write it in vectorial form, so magnitude of the force would be K Q1 Q2 divided by R square and R. So this R hat represents the direction, right? And you guys already know that this is unit vector, right? This only represents the direction. And what is the magnitude of this thing? What is the magnitude of this R hat? Okay, so when I will revise that vectorial portion, then you guys will see, right? So magnitude of this thing is 1, right? Because it is a unit vector. So magnitude of this thing is 1, right? Same like I hat, J hat, and K hat. All of these unit vectors, the magnitude of all these vectors is 1, right? Okay, so this is about the direction and the dependence on the medium. Now, we can also have, right? So let's talk about the force in the medium. So let's say that we have these two charges, same two charges, and we put this thing in some medium, right? So this is some medium. Now, what will happen is that instead of, so earlier it was, let's say this is R. So earlier force was K, or let me write it as 1 by 4 pi, and this was Q1, Q2 divided by R. So instead of, because this is a medium, right? So instead of epsilon naught, this will become epsilon, right? Where this epsilon is permittivity of the medium. I can define a constant, another constant, right? So I can define a constant which is the ratio of this thing by the permittivity of the free space, right? I can define this ratio as R also. So this is called the relative permittivity. And this is also called the dielectric constant. Right, both are same. So sometime it may be denoted as K, sometime it will be denoted as ER. Right. So both are same. And this K is the dielectric constant. So if I find out this value of epsilon, so this would be K epsilon. Right. And if I put this back in this one, so what I will get? I will get, this is F medium, right? So F medium is 1 by 4 pi epsilon naught and K, and then Q1, Q2 divided by R, right? And this K is always greater than, right? So this thing, right, this Q1, Q2 divided by 1 by 4 pi epsilon naught R square. What was this quantity? What was this quantity? This was the actual force when there was no medium, right? When there was no medium, so this was simply this thing, right? So I can write this thing as F air divided by this. So can you guys tell me that force is decreased or increased in the medium? Yeah. Force is increased or decreased? What can you guys say about the force? Yes,
It's increased.
it's what increased or decreased?
Increased, I guess.
Increased. So Mariam is saying increased. What about you, Zara?
I think the same, increased.
Same. Okay. Mm, with the majority, right? Majority seems always right. But let us
I
check this.
think it's wrong.
It's wrong. Okay, so do you
Yeah.
want to change your answer?
Yes.
Okay. And so Mariam has it will be decreased, right? So Mariam is saying that it will be decreased. What about you, Zara?
I don't know. I guess it's, I don't know.
Okay, so let's say that F air, let's say this is 3, right? And let's say this is F medium. Now, if I divide 3 by a number which is greater than 1, let's say 2, right? So this thing would be increased, 3 would be greater than 1.5 or 3 would be less than 1.5. What can you tell? Because this answer is 1.5, right? So F medium is 1.5 and F air, this is 3.
Yeah, so it will
So
be decreased.
decreased, right? And
Yeah.
this is by some example we can understand, or we can also understand this thing. So we can also understand this thing by using this. So how we can use this thing? So let's take this K. This K would be F air divided by F medium, right? So F air
Oh,
and F medium, this K is greater than 1, right? So if I put this thing, so this F air would be greater than F medium. So F medium is small, right? Here. So I can use some example or I can use this idea. Okay. Is it clear, all of you guys? Is it clear?
yes.
So whenever we put the charges in some medium, then the force will decrease, right? So what do we understand? with this thing that the force will decrease in the medium. And one more thing is important to note is that the value of K in water is 80. So dielectric constant of water is 80, right? So if I put the charges, these two charges in water, then if I measure the force, then it will be decreased by 80 factor, right? 80 times it will be decreased. So that is the force in the medium, right? There are now with the idea of these things, right? We can solve different numericals, right? So these things you guys already know, right? So no need to note it down. Or do you guys want to note these things down? Yes. You guys want to note these things down?
Sir, actually, I already have these notes from Amna ma'am's class,
Oh,
so
yeah,
it's
yeah.
fine.
So yeah, it's fine. So then let us do the numericals, right? Because that is the final goal. So and what about you, Zara?
Sir, I already noted it.
Oh, good.
The important points
Yeah,
that I
important.
needed.
Yeah, good. So we have to we have to understand these things in such a way that whenever these things are asked in the exam, we can just quickly think about these questions, right? So solving a numerical needs what? What is the idea of every numerical that we want to solve? What is the key idea? Yes. What is the key idea of every numerical?
To understand it, to understand the
Yeah.
concept of the question properly.
Yeah. So every numerical will have certain information, right?
Yes.
And then you have a certain set of formulas. And then the final thing is that you have some unknowns. So you have to connect the formulas with the information to get the unknowns. That is the idea of every question, right? So what we will try to understand every question and then and then we will try to figure out how we can solve all these questions, right? That is the idea. Insert semicolon. Okay. Yeah, so let us solve this question, right? So the electrostatic force of repulsion, right? When they say repulsion, which means that the charges are what? They say that
Like charging.
they are like charges, right? So we can take positive. So two positively charged, right? So we have two positive charge. Let's say the magnitude rho. They have already given the magnitude. Positively charged things, and they are so we have missing information, right? When they are separated by, let's say, 5 meters, right? So let's say that because this has to be some unit, right? So let's say that this is 5 meters. Okay. So they are separated by 5 meters. I don't know if we get these options or not because we don't know the unit of this question, right? But let's take that this is 5 meters. Now, how many electrons are missing from each ion? Right. So what is the thing that we have to calculate? What is given? What are the things which are given?
Magnitude of the charge and distance is given.
So this is Newton, right? So what is the thing that is given?
Oh, force is given.
Force. Force is given, right?
Oh,
So
yeah, I
force
didn't.
is given. is given, which means that charge is not right. So I was wrong. I said that the charge magnitude of charge. So this is the force which is given. The electrostatic force of repulsion is 3.7 into 10 to the power minus 9. Right. So they have given the force. They have given the separation as well. Right. Which means that what we can calculate from this thing. Using the Coulomb's law, what we can calculate?
Can calculate the charge.
Absolutely correct. So using the Coulomb's law, this is Q, this is Q. We can calculate the charge. So this Q square, this would be FR square divided by Q. Right. And now another, so far, up to this point, what are the formulas that we have understood so far? This one we have used just now. What is the other formula that we have studied so far? Which can relate to this problem? How many? Many signifies what? Many signifies number of electrons.
So the quantization.
Absolutely correct. Right. So Q is NE. This is the number that we have to find out. This thing we can calculate from it. Right. So that is the idea. So now we have figured out how do we have to approach this question. So let us solve this thing step by step, right? So Q would be, let's say Q square. This is F. How much is that? 3.7. I don't know what was the unit in this question, but let's say how much we get. So 3.7 into 10 to the power minus 9, and R square, which is 5 into 5, divided by this K, which is 9 into 10 to the power 9. Right. So this would be how much? Okay, so this is 10 to the power minus 18, right? And you see that in the left-hand side, we have a square, right? So we should not solve this square, the complete square. So let's keep it as 5 into 5. And then this is 9, right? And then we have 3.7. So what would be Q then? Q would be root of the whole thing. And 3.7. So what would be this thing? This would be 5. And this would be 10 to the power minus 9 divided by 3. And then root of 3.7. So now we have to use the calculator, right? What is this value? So this value is 3.7 and root. So this is 1.9. Right. In 3 5, so we can write 1.92 and then multiplied by 5 and divide by 3. So this is 3 point, okay, this is 3.2. So 3.2 into 10 to the power minus. This is the charge that we have. Right. This is the charge that we have. And we can relate this thing with this quantization of charge. So second part is that Q is NE. So we can calculate this N as Q by E. So this Q is 3.2 into 10 to the power minus 9. This is 1.6 into 10 to the power minus 19. So this thing would be how much? So this would be, let's say 2, right? And then this would be 10 to the power, how much? 19 minus 9. So this would be 2 into 10 to the power 10. Right, so this would be the number of elements. So this should be the answer because we have used meters. Right, we have used meters. We didn't know what was this thing, but 1, and what is the answer that 1B, right?
Hmm.
So 1B, but there are some units, the multiples of 10, which is missing in the answer, or we have also some units which is missing in the answer, right? So that would be the answer of this question. Is it clear? Is this thing clear, guys?
Yes.
Okay, then please note down this answer. And if you guys have any question, any doubt in this question, please tell me. Whenever you guys want me to scroll down the screen, please.
Sure, I noted.
Okay, good. What about you, Mariam? Yes, noted, Mariam. Yes, hello, Mariam. Can you hear me? Did you note it down? Okay. Oh, so you have noted. What is this sign? You have a question.
No. Actually, in chemistry class, once we finish writing, we raise our hands. So I felt to do.
Oh, okay. So, okay, so then there should be the thumbs up sign, not the. So
Okay.
this
Okay.
means that you are asking the question. Yeah, this one is correct, right?
Okay, sir.
Yeah. So I don't know about the signs because. Okay, good, good. Yeah. So now let us do the second numerical. And all of these would be related with the coulombs, right? So, and if you have done already these questions, then yeah, these things would be repetitive for you. But let's practice all these questions, right? So then this will give you, if you solve so many questions, then it will give you some confidence to do these problems in your exam, right? Okay, so a free pith ball A of 8 gram carries a positive charge of this thing. What must be the nature and magnitude of charge so that should be given to a second pith ball B fixed 5 centimeter below the former ball so that the upper ball is stationary, right? So we have two pith balls, right? Let's say this is one pith ball, and then this is the another pith ball, right? And the separation between them is, let's say, how much? 5 centimeters, right? Now, what we want to do is that a free pith ball A of 8 gram. So this one has 8 gram mass, right? And we are fixing this. So this is in the air, right? This is in the air, and we want to fix this thing in air. So what must be the nature and magnitude of that charge should be. So if this thing is in the air, then what is the force which is acting on this thing? Forget about this charge as of now. So if we have only this thing which is in the air, what is the force which is acting on this thing? Yeah, if an apple is in the air, then what is the force acting on that apple?
Gravity.
Gravity, right? So this thing will want to go down. It will tend to go down, right? That is the nature of this thing. So it will go. So one force is mg, right? This is A and this is BP. Now this has some charge which is 5 into, so this has a positive charge, right? 5 into 10 to the power minus 8 at 2. So now if I want to fix this thing in the air, so what is the force that I require to balance this thing? I want to keep this thing at equilibrium. So what is the force or what is the direction of force I will require? Downwards or upwards? To balance this
Upward.
thing. Upwards, right? So I require a force which is upwards. And what is the only force that I can create from this pith ball?
Force of attraction. Yes.
If it will attract, then it will support this thing to go down, right?
Hmm.
So the force should be repulsive, right?
Yeah.
So the charge of this thing, nature would be what? Positive or negative?
Okay.
Yes?
Negative. Hmm.
Negatively
Positive.
attract positive, right? Good. So this completes the one answer. So what would be the nature? Nature would be positive. Thus the charge would be positive so that the Coulomb force is upwards, right? Now we are fixing this thing in the air. So that means that this Fc should be equal to what? This mg. Correct, guys? To fix it in the air. Right, guys?
Hmm.
So let's say that what must be the nature and magnitude. So let's say that it has a Q charge, right? So Fc would be how much? What would be Fc? Coulomb force. What would be Coulomb force?
Q1, Q2 by R square.
Yeah. So K Q a 1 Q is given, right? 5 into 10 to the power minus 8. And then this Q we want to find out divided by separation is also given, right? 5 centimeter into 5 centimeter. And this is in Coulomb. So this is in SI unit. And M is how much? That is 8 grams, right? So this is not in the SI unit. G is 10, right? Meter per second square. So what is the only unknown that we have? This Q, right?
Yeah.
So this K is 9 into 10 to the power 9. And then 5 into 10 to the power minus 8. This is 5. Centimeter is 10 to the power minus 2. 5 and 10 to the power minus 2. This 8 gram is 8 into 10 to the power minus 3 kg. And then this is 10. So now where is this Q? So this is the Q. So how much we can cancel? Let's cancel this thing and this thing already. And now let's take everything in the other side. So Q is 8 into this would be, let's solve this thing 10 to the power minus 2. And then this is minus 2, and 5 divided by this 9 into 10 to the power 9 and 10 to the power minus. So 8 fives are 40 divided by 9. So let's write it. Yeah, let's write it 9. And then let's write the multiples of this thing. So 10 to the power minus 6 and plus 8 minus 9. Right. So all of the powers we have considered. So how much is this thing? So this is 9 fours are right. And then again 4.4 into 10 to the power, how much is this thing? So 8 minus 9 is minus 1 and then minus 7. Right. So this would be the answer. Do we have this option? So 4.36, right, into 10 to the power. So this is the nearest one. Right. This is the nearest one. So order is 10 to the power minus 7. So this is the nearest. Right, guys? Is it clear?
No.
Yeah, then please note this one. Please note down this question. And if you guys have any doubt, please tell me. So this would be paused, right? Yeah, whenever you guys have completed, please tell me.
Yeah, noted.
And what about you, Mari? Wait for Mariam to complete this thing. Yeah, whenever Mariam you have noted, please tell me.
Sir, I finished writing.
Oh, good. Good. So now let us do the next question. Right. So this question combined the other concept. This combined the gravity with the uh, electric charges, right? So Coulomb force and then Newton's law or Newton's law of gravitation. Both the concepts were combined in this question. So now let us do the next question, right? Okay, before we do this question, let us do one identical question which will give us the idea, right? So let's say that what happens if we change the parameters, right? So let's say that so the question is that what happens when the magnitude of charges is double and the separation, right, is halved. Confused. Right, so we have two cases. One case is that we have two charges, let's say Q1 and Q2. Separation is R. So force is simply K Q1 Q2 divided by R. Right. Now in the new case, what happens is that we are increasing the magnitude of the charge. So this becomes 2Q1. This becomes 2Q2. And the separation is half. Right. So what would be the new force? F new, let's see, F prime. So this would be K and 2Q1, 2Q2 divided by R by 2 and R by 2. So this would be how much? 4 K Q1 and Q2 divided by R square by 4. So this is the denominator of the denominator. So it will go in the numerator, right? So this will become 16 K Q1 Q2 divided by R. So this thing we have already calculated, and this is F. So the new force would be 16 times the old force. Right. This thing you guys have already. So there is one very important question. And that question will, right? So yeah, please note down this. Right, that question is very important, and that can be asked in the exam. But before we do that, please note down this question. This will give you the idea that what happens with the force when the parameters are changed. Please note it down. Yeah, whenever you guys have noted that. Okay, Mariam has noted. What about you, Zara?
Yes, sir, I noted. I gave thumbs up.
Oh, you have also given it.
Yeah.
Okay, good. Yeah, so the this one is, and I guess that you guys have also done this question in your class or school at some point, but this is very important, right? And the question is that two charged balls A and B having magnitude plus q and minus q are separated by distance r, right? 25% of charge from A is taken out and given to the charge B, right? Find out keeping, yeah, so the idea is that keeping the separation same. Find out the relation between old and new force. Right, so yeah, have you guys done this question before? Yes? Have you guys done this question?
Kind of. I don't actually remember, but yeah, we have done similar questions.
Yeah, so let's, okay, so let's do this question, right? Yeah, so the again we have two cases. Again we have two cases. And what are those? So a case one. We have two charges. This is plus q and this is minus q. And the separation between them is right. So if I calculate the force, of course the force would be attractive. So this would be k, q and minus q, because I am only taking the I have already taken the direction. So let's take q, and this would be r. So this is k q square divided by r. Right. Whenever I am calculating the magnitude of the charges and I have incorporated the direction, so let's say I calculate the force at this point. So force would be in this direction. Whenever I have taken the direction, which means that I have already incorporated this minus sign. So no need to write this minus sign anymore. Right. Now, the second case. So second case is that this is some charge A and 25% is taken. Right. So what would be this charge? So this would be Q minus 25% of Q. That would be the charge on A, right? Right, guys? So how much would be this thing? So this would be Q minus 25%, is 100, and then Q. So this is 4. So this would be Q minus Q by 4. So 4Q minus Q by 4. So this is 3Q by 4. Right. This is the charge which is remained in this charge ball P. Now in the B charge, right, 25% is given. Right, so this would be how much? This would be minus Q plus 25% of, again, not minus Q, but this charge, because this is the charge which is given. So this would be minus Q plus 25 by 100. And then this is Q. So this is again Q by 4. So minus 4Q plus Q divided by 4. So minus 3Q by 4. Right. Right, guys?
मैं कर लूंगी अम्मा, मेरे पास हाथ है
करनी ना
और अरे कौन सा
लग सकता है मैंने भी ना जाके उस घर को साफ सुथरा कर लूं।
चार
Yes, sorry.
दिया है
कॉटन की बिछा लो
Your
वो
mic
वो
is
चलेगी।
not muted. Yes.
नहीं लगता है बेटा, कोई आ रहा है तो अपना घर साफ सुथरा रहना है।
Yes. Yeah. Okay. So this. So these are the new charges that we have, right? And the separation remains the same. So the charges are, this is 3q by 4, and separation is r, and this is minus 3q by 4. Right. So what would be the new force? This would be k, and 3q by 4, and 3q by 4 divided by r. So this is 3 threes are 9 by 16, and kq square by r square. So what was this kq square by r square? This was the old force. So the new force would be 9 by 16x. Right, is this thing clear, everyone? Is it clear, guys?
Yes, sir.
Okay, then please note it down. So, yeah, this one is a very important question, right? This can be asked in your 3 marks. So please note it down, and whenever you guys have noted it down, just give me a sign. So now we can go to those questions that we were practicing. Okay, I have to update this thing in this toolbox. Yeah, today I will give you guys some questions. Please, as your homework, so please try those questions. And whenever you guys want me to scroll down the screen, please.
So scroll. Can you scroll down a little bit?
Yes, yes.
Yeah. Thank you.
Yeah. Yeah. So no class assessment today. They will be doing here. Best in 40 years. Today will be something. Yeah, even you guys have to just give me some. Yes, whenever you guys have okay. Okay. Noted, guys.
Yes, sir, done.
So I have noted.
Oh, both of you guys. So why didn't you guys just give that thumbs up?
No, I
Okay, so
just
Sir, I gave the thumbs up.
you guys gave, but I didn't see in the chat. Okay. So maybe I missed that. So yeah, so it's already because why did I do those two problems? Because I saw that each sphere is charged double the above amount and then distance between them is half. So that is why I did those two parameters, right? And yeah, so in the next class, we will solve all these problems. So there are numerous questions and we will solve all these questions, right? Okay, so in the next class, I will solve all these. So these are very important questions. And I can see that there is this equilibrium also. So which means that we have to also talk about equilibrium, right? Yeah, so we'll talk about equilibrium.